Howdy punchers, and welcome back. Today we're going to be solving equations with variables on both sides. Let's get into it. All right, so this is like a puzzle, right? So it's like x is some number, okay? And we plug in numbers and try to figure it out. Only people with over 1,000 IQ will know this. But what if I told you, see that 4? You see that 4? That 4 means x equals 4, the solution. We can solve all types of problems like this, no matter how complicated. See this really hard puzzle? Boom, x is 9. All right, for this week's spell work, we're going to be using this equation at the top for the entire series of questions. I'm going to go ahead and paste that in Desmos so that while I'm working, I don't misremember something and type a incorrect equation because I totally didn't do that already, and this is my second time making the video. Go to Desmos and graph this first half of the equation. So I'll copy that, Desmos, bing, bang, boom, graphed. All right, take a screenshot with it. All right, in Desmos, graph 2x, the second half of the equation. All right, and so I'm going to turn off my first line. It just wants the screenshot of 2x. Boom. Click and drag or zoom out until you can see the two lines intersect. Click that point and have it display as an ordered pair, then take a screenshot. All right, so I need both of my lines on. I can't really see where they intersect, so I could either zoom out and find that intersection, or I could drag and click where I can see that intersection. Now, if I just hover over that point, it'll show up in gray. I want to click it so it stays on, and I can take a nice screenshot. Hit that. Again, I want both my lines and the labeled point. So if I didn't get that screenshot with that point labeled, I want to make sure that that is on. Question, does your solution have both an x and a y component? So will the solution to our original equation have both an x and a y component? Good question. Now, I'm not going to answer it for you because you have the same question. Why or why not? So think about that. I don't see one of those variables at all in the equation. There's an auspicious absence of it. So do you think it'll be in the solution? And then why or why not? One or two sentences, plural, because you have two questions to answer. All right, verbatim question from the last state test. What is the solution to the equation 5x minus 3 equals 2x? It's only one variable of this equation. What do you think your answer should look like? It's a good question. Thankfully, it already has x equals something. So what could that x be? Well, it probably looks like x equals 10. Oh, right. I write these x, y, so it should be x equals 5. Does that look like that hits our solution? Yeah, that's the x components. There you go. X equals 5 to be our solution. All right, let's do one more of these for you all at home. Maybe not doing my bell work or doing it next week because it's going to be the same as you do. All right, let's say we got a different one. We got a big brain stuff. All right, so let's pretend you're in algebra 2, okay? And you've got a crazy quadratic quiz question that looks like this. So let's just put them both in Desmos. Take this half of the equation, put it in there. Obviously, it'll be a curve instead of a line because we've got x squared. Put this equation in there, blam. Don't be scared. There are some extra points here, like a vertex and an x-intercept. But these are the 2 points where these two curves intersect. So I'm going to make speculation that when x is 5 or x is 0, these two will be equal. So let me copy this. And let me put in some different numbers here. When I plug in 5 for both of these equations, I do get a true solution. They're both equal to 5, and 5 is equal to 5, so I know that's correct. Let's try 0. Yep, and when we put in 0, obviously 0 minus 0 is equal to 0 times something because it's 0. So that's kind of a trivial solution. But bam, 0 and 5, when x is 0 and x is 5, you have solutions to this equation with x squared values on both sides. So as you can see, no matter how complex you have of an equation with just a single variable on both sides, you can solve it by simply graphing both in Desmos and finding the point or points, if you're in a higher order equation, where they intersect. And those will be the solutions, where x is equal to that x component of the point. Done, easy peasy, lemon squeezy, ready, set, go, do it, get it done. Bye-bye.